Hi dear viewers, I am Kalaivani from Business College of Pharmacy and Health Sciences. So today we are going to discuss about the mevalonic acid pathway. The mevalonic acid pathway is used for the production of terpene hydrocarbons that often have a use as secondary metabolites in plants. The pathway begins with two acetyl-CoA which bind together using the enzyme acetyl-CoA acetyl transferase, which is called as CoA acetyl transferase. The product is acetoacetyl-CoA. This then reacts with another acetyl-CoA in the presence of beta-hydroxy beta-methyl-glutaric acid. Glutaric CoA synthase forms beta-hydroxy beta-methyl-glutaryl-CoA. Next, the beta-hydroxy beta-methyl-glutaryl-CoA reacts with the two NADPH and two protons and the enzyme beta-hydroxy beta-methyl-glutarate CoA reductase to form mevalonic acid. Mevalonic acid is a hydrocarbon that is not linear, and the mevalonic acid is then phosphorylated using ATP with mevalonic acid kinase, followed by ATP with phosphormevalonate kinase. This is mevalonic acid 5-pyrophosphate. The T-pyrophosphate is used when two phosphorus are adjacent. The mevalonic acid 5-pyrophosphate that becomes the building blocks for tyrine synthesis. The mevalonic acid 5-pyrophosphate reacts with ATP and the enzyme the bisphosphomevalonate decarboxylase and inorganic phosphate and yield isopentyl pyrophosphate. The pyrophosphate can be called an isoprene unit. It has 5 carbons with no oxygens and can serve as the basis for other more sophisticated hydrocarbons. The isoprene pyrophosphate can be isomerized. The reaction is reversible using the same enzyme. These two, the IP and the DMAP, there's dimethyl pyrophosphate. The formation of terpene, rather than trying to write these out with all carbons and hydrogens involved, we are going to aggregate these into line figures. Man in the line represents the location of a carbon. The isoprene pyrophosphate will be representing like this. And the dimethyl pyrophosphate will be represented like the molecule of IPP and one molecule of DM combined to form one molecule of genyl pyrophosphate. And the reaction causes the release of pyrophosphate molecule. The genyl pyrophosphate will have 10 carbon next to a molecule of IP will react with the genyl pyrophosphate to form a molecule. And if this is pyrophosphate, then fossil pyrophosphate will have 15 carbon atoms. The fossil pyrophosphate will react of IPP genyl pyrophosphate with 20 carbons. Each combination will cause the release of pyrophosphate. Larger molecules were formed by the combination of fossil pyrophosphate with 30 carbons or with the combination of genyl and the pyrophosphate with genyl or 40 carbon atoms that is tipping or often basic chemicals with the secondary metabolites of plants. So this is about your mevalonic pathway. Let's see the significance of mevalonic acid pathway. The mevalonic acid pathway is a major biosynthetic pathway which involved in the formation of isoprenoids, that is terpenoids, in plants, animals and microorganisms. So it produces isoprene units, that is IPP and DMAPP, which are the basic building blocks for terpenes and terpenoids, steroids and sterols, cardiac glycosides, essential oils, etc. So, coming to the pathway is essential for cell membrane structure, that is cholesterol and phytosterols, and the cell growth and signaling, hormone synthesis, and MVA pathway, that is mevalonic acid pathway, has a high pharmaceutical importance too. It is the target of statins used to reduce cholesterol. Produces many medicinally important compounds like menthol, camphor and taxol. So in plants it mainly operates in the cytosol and in animals it is the only pathway for cholesterol synthesis. So that's a summary of the significances. Major pathway for isoprenoid and terpenoid biosynthesis, produces sterols and steroids, essential for cell membrane integrity and cell growth, source of many medicinal compounds, that is cardiac mechanisms, essential oils, important drug target. So the limitations coming to the part, energy intensive, require ATP and NADPH, not the only pathway for isoprenoids in plants. MEP pathway also exists and occurs mainly in cytosol, limiting some plastid terpenes, and the overactivity leads to cholesterol related disorders. Inhibition affects normal cell functions. So these are the limitations and significance of the mevalonic acid pathway. So hence the MEA pathway is a vital for terpenoid and steroid synthesis, but is energy consuming and partly limited by cellular compartmentation. Thank you.